Okay. Good evening, one and all. Myself, Dr. Balaji Maram, Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, Telangana. Today, the concept name is IP security. Here, what security problems? Today, everything is depends on internet only. It could be LAN, MAN, WAN, or public internet. Here, the internet is primarily comprised of public, untrusted, unreliable IP networks. Because of this inherent lack of security, the internet is subject to various types of threats. Because of some loopholes or drawbacks, or limitations in public internet, definitely because of this reason we are facing lot of problems. What are the threats? First one is data integrity. In data integrity, when sender sends something, the receiver receives data. But the receiver don't know whether the received data is really sent by the sender or any hacker. That is the main problem in this scenario. Here, definitely, uh, there is a need to check the sender's sender's data and the receiver data if both are same or not. How it is possible? It is possible through MAC or hashing. Okay. Usually we are using MAC, message authentication code. The MAC is generated from the original message, and the MAC code will be sent to the receiver. Then the receiver receives the message and MAC. After receiving the message, the receiver checks whether the received message is the original one or altered one by calculating MAC of the received message, and he will check both are same or not. Miss received MAC and calculated MAC if both are same or not. If both are same, then it is original message. If both are different, definitely it is the altered message, altered by some middleman or some hacker. Okay, that is about data integrity. Second one is identify spoofing. Is the origin of an IP packet can be forged. Okay, so the original packet and the forged packets both are entirely different. The original packet contains original data. Forged packet may contain some altered data. Okay, and third one, anti-replay attacks. Usually, when some communication is happening between sender and receiver, uh, both are listed. Just assume both are legitimate users, and the sender sends the data, the receiver receives the data, but the middleman or hacker, he saves some packets which belongs to sender and receiver. Those are those packets belongs to actual communication, and everything is genuine. So in that scenario, the hacker sends the same packets once again after few days, maybe after few days or few months, whatever it may be. It depends on their necessity. They will replay the packets, but the receiver don't know whether these packets given by the sender are hacker, because everything is genuine. That is about third one. Fourth one, loss of privacy. This loss of privacy means when the communication is being observed by some hacker, definitely it is comes under loss of privacy. Maybe there is no physical damage in the content, but it is being observed by some third party, and they will assess something. Okay, they will analyze something. So that is comes under passive attack. This in previous classes we have discussed about attacks, passive attack and active attack. So in that scenario, definitely loss of privacy is comes under passive attack. Here, first of all, we need to understand the TCP/IP communication. The left side, it is ISO OSI reference model. The right side, the actual picture of the communication, that is nothing but TCP/IP protocol suite. Left side, you can find application layer, presentation layer, session layer, transport layer, network layer, logical link layer, physical layer. And in TCP/IP protocol suite, you can find application layer, TCP, UDP layer, IP layer, device driver layer, network adapter. Okay, both comes under same layer only, device driver and network adapter. Total four layers will be there. In application layer, you can find different protocols: FTP, SMTP, NFS, DNS, FTP, SMTP, HTTP. So like that, you can find various applications under application layer only. Now, here, how the packet or how the data is being transmitted from source to destination. In source side, means different layers, and destination side also the same set of layers will be available. So when the sender sends something, that is nothing but original message in this picture. The original message is nothing but data 3. For data 3, you can find when it reaches transport layer, you can find one header that is added to the data 3. Then when it go to network layer, one more header will be added, that is header to data 2. Then data link layer, the entire thing will be comes under data 1 now. Okay. Actually, original message is topmost, and after adding some headers, the bottom one is the actual the generated message. The generated message will be passing from source to destination. Okay, network layer to data link layer to network layer to data link layer. Okay, this is packet. Okay, the packet received by the host B. The host B, that is packet is nothing but it is a combination of header 1 and data 1. That is being received by the data link layer. Then the data link layer detaches that particular header, and it process data 1 to the upper layer, and the upper layer is network layer. In the network layer, that is divided into two parts. So first one is header part, second one is data two, actual data part. Then this after detaching header two, the data two will be going to upper layer, that is a transport layer, and the data is divided into two parts. First one is header part, second one is data part, that is header 3 and data 3. And header 3 will be detached, and the data 3 will be going to the next layer, that is application layer. That is nothing but the original message. Actually, the sender sends some data. That data is received by the receiver side, that is received by the application layer. Okay, that is nothing but the original message. Here, security at what level? Here, you can find four layers: application layer, transport layer, network layer, and a data link layer. Under application layer, you can find some of the algorithms: PGP, Kerberos, SSH, etc. And regarding transport layer, earlier we have discussed about SSL and TLS. Here, TLS is belongs to transport layer. When we talk about network layer, IP security plays a vital role. Next, when we talk about the data link layer, hardware encryption plays a vital role. Now, IP security. Generally, IP security provides different services. That is authentication service, confidentiality, next key management. Okay, these three are very important when data is under communication. Okay, this process is applicable to use over lands across public and private WANs and for internet. Okay, this is the actual communication. System with IP security, IP security without IP security, with IP security. So when there is a IP security, and IP security, IP header will be there, IP security header will be there. Next, secure IP payload. Payload means that is nothing but data only. Okay. So that is being transmitted between different types of a system to system, client to server, or server to client, or router to server, or router to client, different. Okay, and after reaching the actual LAN, then automatically that IP security header will be detached. Then two parts will be there, that is IP header and IP payload. Okay, just you can find in the picture when it reaches the destination LAN or destination system, automatically the data will be nothing but IP header and IP payload only. What are the benefits of IP security? In a firewall, a router provides strong security to all traffic crossing the perimeter. Okay, so when it is a in a firewall or in a router, it provides strong security to all traffic crossing the perimeter. In a firewall, a router is resistant to bypass and is below transport layer, hence transparent to applications, can be transparent to end users, can provide security for individual users, secures routing architecture, secures routing architecture. And here the IP security architecture. Okay, here the specification is quite complex and it is defined in numerous RFCs, including RFC 2401 and something, and many others grouped by category. But here the IP security is mandatory for IPv6 version. Okay, version 6, but it is optional for IPv4. And here, the IP security is a combination of two security header extensions. First one is authentication header. Second one is encapsulating security payload. IP security services. What type of services it is providing? Access control, connectionless integrity, data origin authentication, rejection of replayed packets, confidentiality, limited traffic flow confidentiality. Okay. Here, access control, connectionless integrity means integrity, that is through connectionless, and data origin authentication. Here, the sender proves its authentication. Okay, and a rejection of replayed packets, already we have discussed. When any hacker saves the original packets, and after few days or few weeks he will replay the same thing. So that is nothing but rejection of replayed packets. Confidentiality, it provides confidentiality also. Limited traffic flow confidentiality. Okay, this is comes under passive attack. Before going to discuss about AH and ESP, there is a need to discuss about security associations. What is security association? It is one-way relationship between sender and receiver that affords security for traffic flow. Means definitely when there is a communication, this communication should be initiated and they should agree what type of algorithms, what type of values should be exchanging between these two nodes or client and server, whatever it may be. So that relationship is comes under security association, and it is defined by three parameters: security parameters index, IP destination address, security protocol identifier, and it has a number of other parameters we will discuss in detail. That is like sequence number, AH and EH information, lifetime, etc. And it has some database of security associations. Definitely, different corrections will be there. and different security associations will be there. But for maintaining all these things, one database is must. What are the components of a security association? First one is security parameters index, a unique identifier assigned to each SA to differentiate multiple associations. Because it is like one type of agreement between the sender and receiver. For each and every agreement, one sequence number should be assigned, and those sequence numbers should be unique. Then only uh, we can differentiate between security association to another security association. That is comes under security parameters index. Second one is encryption algorithm, and it specifies algorithms like AES and DES and a key used for encrypting the data. Okay, here it is strongly binds with symmetric key cryptography only. That is the reason there is a need of symmetric key cryptography algorithms, AES, DES, etc. And third, authentication algorithms defines the method HMAC SHA-256 for ensuring data integrity and authenticity. Definitely, these are the methods HMAC and SHA-256 for ensuring data integrity and authenticity. Next one, lifetime, may specify the duration for which the SCA remains valid before requiring renewal. Here, like our passport, definitely there is a need of renewal. After expiry date, there is a need of renewal. Here also same. For each SCA, some validity period will be there. After validity, there is a need of renewal. Next one, mode of operation. It defines whether SA operates in a transport mode, that is like end-to-end communication, or tunnel mode, that is gateway to gateway communication. Okay, this is a small difference between transport mode and tunnel mode. Here, outbound and inbound IP security processing. So here, two systems are there. The packets are moving here and there, and inbound means incoming packets, outbound means outgoing packets. Those are completely independent. Okay. Okay. The first header in IP security, that is authentication header. So here, authentication header simply provides authentication. That's it. So what type of fields are there under authentication header? First of all, it provides support for data integrity and authentication of IP packets. Both services it provides, that is data integrity. It provides data integrity. Also, it provides authentication. Is here end system or router can authenticate the user. Okay, suppose some router is there, some user is there, or some server is there, whatever it may be. Definitely, the authentication is required. The second point is prevents address spoofing attacks by tracking sequence numbers. Okay, it prevents address spoofing attacks by tracking sequence numbers. Next one, based on the use of Mac. Based on the use of a Mac. Earlier also we have discussed that Mac is must for both AH and ESP. And last point, parties must share a secret key. Already I told it is strongly binds with symmetric key cryptography only. So that is the reason. Definitely there is a need of shared secret key between the sender and the receiver. Next, this is the picture of authentication header. The first one, network means next header means what is the next header? Some packet is there. What is the header of next packet? So that is nothing but next header. Next one, payload length. Here, payload length means it is nothing but the size of the actual data in the packet. And the third one, reserved, means we should not discuss because it is a reserved space for future usage. Next one, SPI, Security Parameters Index. Earlier also we have observed what type of algorithms they are going to use, what type of values they are going to use. what type of seed values are necessary, and what type of salt values are there, like that. What type of MAC algorithms are there, like that. You can find such points before going to start the communication between send and receiver. Okay, they should agree. Means I am able to provide these things. Suppose client side, in server side also, I am going to provide these things. So if both are matching, then okay. Otherwise, they need to change their means mindset. We suppose sender is ready to use AES and receiver ready to use DES, but both are different. So that is the reason both should agree either on AES or on DES. Okay, that is nothing but security parameter index. Next one is sequence number. For every packet, one number should be there, one unique number. That is nothing but sequence number. Next one, authentication data. Authentication data. So here, already I told, authentication means it is possible through MAC or hash function only. Okay. When it is a MAC, first of all, there is a need to calculate the MAC value. Then that MAC value will be included in this space. Okay, so here it is like a variable, its length is variable because we can't find the fixed length. Okay, this is about authentication header. Now this is earlier we have observed transport mode and tunnel mode, and this is a simple picture. Okay, here, some client server communications are there, and some arrows are there. That is nothing but end to end authentication. Okay, end to intermediate authentication. Okay, these are different possible communications between the server client, router to a server. Okay, now, this is the picture. In transport mode, protect the upper layer protocols. Okay, when the data is coming to some layer, that layer is responsible to give the protection to the upper layer data. Okay, so that is nothing but the security means IP security. So here the actual data is like data, TCP header, IP header. Okay, and after that, after transport mode, the protected packet, the entire data, okay, the entire data will be protected except headers. So here header is IP header only. The remaining comes under the protected data. Here, the protected data contains the actual data, TCP header, and IP security header will be under protection. But only the visible part is IP header only. Okay, that is I think but transport mode. The second one is tunnel mode. Tunnel mode means not like transport mode. In tunnel mode, the data as well as the what is that IP TCP, IP header will be protected. Okay, including IP header, TCP header, IP security header, data, and IP header will be protected. The entire thing will be protected. But how to transfer from source to destination? So that is the reason it adds one more header, that is new IP header. New IP header. Okay. This is a small difference between transport mode and tunnel mode. This is the actual picture, host to network, network to network, the communication. Okay, host to network, application layer, transport layer, IP layer, that is given by host, and that is the entire thing will be protected. Okay, including header part. This is transport mode, host to host communication. What about host to host? Application layer to application layer, transport layer to transport layer, IP security to IP security, IP layer to IP layer. DLL to DLL, host A and host B. Okay. The second protocol is that is encapsulating security payload. Encapsulating security payload. So here it provides message content confidentiality and limited traffic flow confidentiality. Okay, and it provides confidentiality, that is nothing but message content and limited traffic flow confidentiality. Second point, can optionally provide the same authentication services as AH. But when we talk about authentication, it is almost similar to AH authentication header. Third point, supports range of ciphers, modes, padding, including different algorithms are there: DES, triple DES, RC5, IDEA, CAST, and so on. And modes, CBC mode, and remaining modes. And the third one, padding needed to fill block size fields for traffic flow. Okay, padding means padding may where it is required. So when data is divided into some blocks and the block size is 128 bytes, just assume. But total 10 blocks are there. 9 blocks are 128 byte size, and the last one may be 100 bytes. So definitely, to make it 128 byte block, there is a need to include padding bits in remaining 28 bytes. Then it will become 128 byte block. Okay, that is the reason padding plays a vital role. Okay. Yes, these are this is the picture. These are the fields. Okay, first one, security parameters index. So already I told, when there is a what is it? When there is a communication between the sender and receiver or client and server, definitely they need to tell what are their capabilities, miss in what way they are going to communicate, what algorithms, what algorithms or what versions, everything. Okay, that is their capability only. Okay, second one is sequence number. Already I told, when there is a packet, sequence should be there and that should be like unique. Okay, third one, payload data. Payload data means already I told, payload data means that is nothing but the actual data which is initiated by the sender, and that is variable length. Its length is variable. Next one is padding. Padding means already just now I have given a few points about padding to fill the gap in a block. Definitely, that process is called padding. Okay, the padding bits are like 0 to 255 bytes. Okay, next one is pad length, means how many bits are added, how many bytes are added to make the block size equal to other blocks. Okay, that is pad length. Next one is nest header. Already header is there for each and every packet, and the nest header part will point to next packet. Okay. Next one is authentication data. Already I told in AH, when there is a need to send some data from source to destination, definitely there is a need to calculate MAC or hash function. Then it generates some output. That output is nothing but authentication MAC. That output is nothing but MAC, and that MAC will be included to the original message. Okay. Then the sender sends two components. One is means data. Second one is MAC code. Okay. So that is nothing but authentication data. Okay, means like MAC. So, transport and tunnel mode. Transport mode is used to encrypt and optionally authenticate IP data. Okay. In transport mode, it is used means purely it is used for encryption and decryption only, and optionally authenticate the IP data. Data protected but header left in clear. Okay. Data is completely protected, but only header is appears like clear. Is a readable format, can do traffic analysis but is efficient. Okay, and good for ESP, host to host traffic, and good for ESP ESP, host to host topic. Okay. Next, tunnel mode. Tunnel mode encrypt the entire IP packet and add new header for next hop. Already you have observed new IP address. Okay, and good for VPN, gateway to gateway security. These are the things which are related to ESP. Next here, combining security associations. Okay, SES can implement either AH or ESP. To implement both, need to combine SES from form a security association may terminate at different or same endpoints combined by transport adjacency, iterated tunneling, and issue of authentication and encryption order. These are different what is it? Combinations. Case one that is like one or more SES means between same source and destination you can find different SES. And case two that is like mode tunnel mode means that is communication between gateway to gateway only. Next, third case, that is like means transport mode, that is like node to node, and tunnel mode also there, that is gateway to gateway communication. And case four, that is like means node to node communication and gateway to gateway communication. Okay, so these are different combinations, and it tells how combining security associations. Okay, now, what are the key management? Handles key generation and distribution. Means already I told. It is like means it is strongly binds with symmetric key cryptography. So when it is a symmetric key cryptography, definitely there is a need of one shared secret key between sender and receiver, and typically need of two pairs of keys, two per direction for two per direction for AH and ESP, and manual key management system. It means manually configures each and every system. And the second one is automated key management, automated system for on-demand creation of keys for SES in a large system, and has Oakley and ISA KMP elements. So here Oakley. It is a key exchange protocol based on DP-Hellman key exchange and adds features to address weaknesses, and can use arithmetic in the prime fields or elliptic curve fields. The second one is ISA KMP, and it is Internet Security Association and Key Management Protocol, provides framework for key management and defines procedures and packet formats to establish, negotiate, modify, and delete SCs. Independent of key exchange protocol, encryption algorithm, and authentication method. This is the picture of ISA and here the first one is initiator cookie, second one is responder cookie, next payload, and a major version, minor version, exchange type, some flags are there, message ID, next length. Okay, this is ISA header. The second one is generic payload header. This is next payload, reserved payload length. Okay. Here, payloads and exchanges have of payloads types, security, proposal, transform, key identification, certificate, hash signature, nuns, notification, delete, and this framework for five types of message exchanges: base, identity, protection, authentication only, aggressive, and informational. Okay, this is like summary. Already we have discussed about all the points. IP security framework, authentication header, and encapsulating security payload (ESP), and key management and Oakley and ISA KMP. These are some important topics. So anyway, till now we have discussed about IP security. In previous class, we have discussed about web security, that is like SSL by TLS. Second one is set. Those are strongly binds with the web security, but this is strongly binds with IP security. Means when we talk about internet protocol, means how to provide security to our data, that is comes under IP security. Okay, so these are different points related to in today's class. Okay, thank you.